Hi, I'm Trent Piazzoni, project architect with NumberTEN, and this is Michael Hiebert, senior technologist with NumberTEN. And I'm going to talk about a project we worked on as a case study where we use Revit Parametric Design and Fabrication. Parametric Design I will discuss later if you don't know what that means, but just basically a case study where we worked on and what lessons learned from it and how the experience was. So the project is set at the Forks Market. Most of you should know, but people out of town, it's a very heavily used tourist destination market that we have. And in 2016, our office did a renovation of the Commons area, which is a beer and wine garden, as well as some restaurants tied to it. And our project is just adjacent to it as part of phase 2. So on the right there, you can see the Commons on the north side, and our project is set in red. There's another bay just to the left of that, and that's a pizza place. But in the enlarged area, we have basically a restaurant that we worked on. It's called Piazzoni, and the one thing, we had a few goals in mind with this project was to utilize every square inch at the Forks. Every square inch is a premium. While maintaining that, we wanted to have everything be on display. The cooking is part of the display process, so we've opened everything up the back of the house. In addition to that, we wanted to maintain an intimate setting for dining. This is a high-end restaurant, and we wanted to try to do that, but also integrate with the Forks as best we can. So in addition to that, there's a corridor that was on the right-hand side. How we were trying to struggle what we're going to do to try to make that corridor and the dining also be intimate, but make a solution to the problem. So we saw this as an opportunity to do something with Workshop 10.
So that's where I'm going to come in. As it was noted earlier, collaboration is one of the really important parts of a lot of BIM projects. A lot of collaboration is essential for some of the best work to occur. And within our office, we've initiated this working group, I guess we would call it, and we've titled it Workshop 10. But essentially what it is a design, research, and fabrication initiative where we pursue and explore the concepts of materiality, of craft, and assembly in the context of modern architectural practice. Within Workshop 10, we try to pursue collaborative relationships with local artists, with other designers, with craftsmen and trades, to engage a full spectrum of design. And we want to use the latest digital technologies all the way to hands-on fabrication. So there's some images here of us working with blacksmiths on some projects, one of them being the Forks. There's the two upper images are actually of this corner of the Red River College building, where we were working with some of the trades to develop a perforated screen that really served the purposes of solar shading within that corner office. And then some other projects that we had done through the Workshop 10 group. And I should say, so we saw, going to go back. We saw this wall as a really important opportunity for us to take on that little bit of a project and perhaps collaborate with somebody to design and build the dividing wall between the restaurant and the corridor as a little mini design project within the greater design project of the restaurant.
So as I mentioned parametric design earlier, what is parametric design, other than a fancy word? Basically, it's a digital, using digital information from a model, geometric information, and also working with the new technologies such as CNC machines, 3D printing, and being able to create sculptural forms from it. Way back when, it seemed fanciful to try to do things like that, but with CNC machines, these kinds of things became much more common to be able to create, and they're not terribly expensive. So we basically just we wanted to try to use this as a tool. If you look on the right-hand image, there are geometric relationships to how big those openings are, and how how much they vary. There's a lot of quality control you can get by having a digital information. So what I did with parametric design, I originally, was what, 8-9 years ago, Revit started creating this tool called Revit Adaptive Components. I originally saw it and thought, well, this is not something I'll ever use because it seems really expensive and I'll never get it used on a project. Well, I changed my mind with all the information that came about, and I'm just going to discuss how Revit, in a large terms, how Revit uses it and creates these forms. So initially, okay, it's readable. Doesn't read up on my screen. On this image on the left, there are 4 arcs that are joined together, and they are on separate work planes. Those come joined together and create a plane of a curvy form, basically. After creating the plane, you can take that shape and then just divide it up in even numbers. So at each of those intersections, it creates a point. So this is, I think, 10 by 10 space, but you can change whatever you want to. So it just literally splits it up. And then you could insert a family, and in this case, it's a triangle shape. This is really what an adaptive component is, and adaptive points. So this triangle can be manipulated and stretched as needed. So each of those from point to point is a length, and the angle between those two is got an angle associated with that. So that's all information that we could use for fabrication. So after placing a triangle, you can all of a sudden fill those gaps and create that shape. Use the triangle because it's an easier to create bendable tools. You get less distortion in it. And then you can start seeing it 3-dimensionally or setting materials associated with that. So we can create thickness, and then if you wanted to, openings and holes that create a little more interest to it. So this is a kind of a broad view description of what adaptive components are and how you can do that. So we started out with the conceptual design, the forks, and at the beginning, we wanted to try to make an aesthetic that complements this historic space but contrasts and evolves the design of the space. So on the left-hand side, we really didn't have a floor plan at the time. We didn't have a tenant. We just kind of thought, well, let's just practice using the tool. And what I used is the arch. I tried to tie in relate the arch to a shape and played with the geometry there. And then when we had a more like the actual floor plan, I looked at trying to wrap it down to create a wall, create some privacy, but that really didn't work out as well as we would have liked it to. Then I explored another option where we had this twisted fettuccine, but it really didn't know what we were going for. But then we kind of decided that this fin wall look was not necessarily this design, but the approach that we like to do and incorporate that with bench seating we have right there. So, so we came to this final conceptual design. And we did what's integrated the bench with vertical fins. And even though it looks relatively simple in form, it was a very complicated process. If you look on the elevation in the bottom left-hand corner, I don't know if you can see from a distance, but we have the ducts. Thank you, my assistant. So we have ducts, we have pipes, we have sprinkler heads, we have all this existing infrastructure that we're trying to work around. And we also decided to make things more complicated for ourselves. We added lighting at the top of the bench and the bottom of the bench to try to incorporate that. So we solved these issues by, as you can see, by having every third stud approximately of a structural stud, and then we filled it up with a lower stud to create that pattern of a V, which allowed all the infrastructure to go through. And then we also were worried about the quality control of the stud spacing made in existing space. So what we ended up doing to control that was laser cut holes. It's a steel bench that we cut holes on center to do quality control again. We get a lot more precision with laser cutting. And we went from there. Let's make some consistency. I think that was everything on that. And I think the next is yours, right? Yeah.
So now that we had some geometry defined in some fashion, we were presented with the challenge of how the heck are we going to build this thing? And so that's where the collaboration again started to come into play. We partnered with a local design builder firm called Design Built, who does furniture, they do houses, they do a lot of fabrication projects. And we approached them to see if they would want to have a relationship with us in terms of getting this thing built, that we would work together on some of the detailing where, you know, you have all these fin walls, but you can see they're not attached to the top and they're not actually attached to the bottom. And it's like, how are we going to do this? So they came and started working with us on the project. And one of the first things that we realized that there was so many variables to consider. The image on the left was just some early sketches of the ideas of where are all the variations on each fin. And that became something that was actually, to be honest, a little bit overwhelming at the beginning of this process where you feel like, holy cow, there's so much that we have to manage throughout this. And so we had to figure out a way of how we're going to address some of the variability in the design. And we realized that two of the most critical pieces were at the angle between the bend in the fin and at the angle that it hit the roof. And so we approached that with the idea of some sort of a hinged solution. And this is the part where I forgot my model. I have some models at the office. That I forgot to bring. I was going to show you guys, but I do have some different versions on the screen here. So we had a few different versions where we were exploring the idea on the far left of a sliding joint that maybe would accommodate the variation from slat to slat, something in the middle that was kind of a little bit more open that, you know, you really expressed the idea of a hinge, and then something that we landed on was the image on the far right. And so that was a really interesting part of the process, trying to model just sort of the minutest bit of detail into the BIM model and trying to represent it so that we could choose options, you know, in an intelligent way. One of the other things that was a little bit overwhelming was this idea of representation. When I looked at this project, I'm like, again, oh, there's so many slats. How am I going to communicate this? Especially when we were looking at different materials. We said, is this going to be a plywood cut thing routed on the CNC machine? Am I going to have to make 75 cut files of each of these and ensure that am I going to be generating the actual file out of Revit that is needed for them to make this thing? And so again, somewhat overwhelming. But as we were working through this with Design Built, we realized that plywood wasn't really something that we wanted from a material perspective, because each of the edges of the fins was going to be exposed to the corridor traffic, which was a heavy use. We were worried about it damage over time. And so we thought, well, what is the approach that we can, how are we going to approach this with solid wood? So as you're aware, solid wood doesn't come in big sheets. So it's like, again, what information are we going to pull from the model that we can use to fabricate solid wood pieces? So the other way that we thought about approaching representation was with some sort of a schedule of materials. Can we generate this from our model directly? Is this information that we have on hand? That we could do this if we wanted, but it turned out that it was actually quite a bit simpler. And it really comes down to what some of the other people have mentioned already, but it's actually just passing the 3D model onto the fabricators. And so I had spent so much time kind of stressing about representation that it actually was just like, hey, here's our model. And then they started building it. It was really quite nice that they could pull all of these parameters out of the model instead of us worrying so much about how it's documented. Here's some of the images from installation when we were in the shop building, planing down the pieces. The only thing that ended up being CNC routed was actually the hinge detail on each of the pieces. The rest was actually all done, turned out to be done by hand. But one of the most critical pieces of the whole puzzle was all the little green tags that you see on the hinges. Each of those was a unique label for the pieces, and that was something that that was critical for us to manage on site. Every time you move these pieces, you have to keep them in order, and they did a really great job of helping out with that. And so then now we get to some of the final images of what we were left with after all of the design and fabrication in the shop. So the image on the left is an image from inside the corridor where you can get some of the transparency through to the restaurant, which was one of the design goals that we had at the beginning. Just a detail image of the hinge that really solved a lot of our variability problems. And then this is an image of the inside of the restaurant as you come in. And I don't know if I forgot to mention it before, but there is also a ceiling detail, which is a continuation of the geometry of the wall. A way to tie in the existing floor joists above and trying to get that material connection between the two pieces. And then I think the one thing that we did want to touch on a little bit was some of the lessons learned in the process. So Trent, maybe.
Yeah, well, sure. Basically, the lessons learned, as Michael mentioned, that we have the model was all we really needed. It was a surprise to us. But so basically, the accuracy of the model was paramount. So we really needed to model every length accurately. And that elevation really kind of showed all our issues that we had to deal with, and we just addressed it. And there was really no issue when things went up, which was surprising since how many issues we usually get on a job. And then the one thing was really nice about this is that this could be where our goal is, that our 3D model actually becomes our documents, our deliverable to the contractor. Where that is our, I think, our main goal. We're not there yet, but our hope is, and it was nice to see that this is actually feasible just from the model itself.
And even on a super small scale project, sometimes there's the feeling that BIM isn't really for the itty bitty things, but it's like, no, this is really good from everything that's super small all the way to the great big hospital projects that you see. One of the other lessons learned that I kind of came away with was the accuracy of the existing space. And that kind of goes to what you said, Sean, about having accurate as-built and things like that. We were on site like 2 times a week, for hours at a time, measuring each of the ducts and each of the joists and all these sorts of things. And that was took a lot of time. So having a laser scanner would be pretty cool. I know that guy can hook us up.
Yeah,
but yeah, and so I think that's maybe the main takeaways that we got there.
I would agree.
All right. Thanks, everybody.